First of all, very good morning to all. And I am Priti Choudhary. I am assistant professor in Ajay Kumar Garg Engineering College in IT department. So, in my last lecture, I was discussed about the stack, and in this lecture, I will discuss about queue. So, in my last lecture, um, I was discuss about the stack data structure, operation of data structure, and also the algorithm of push, pop, and display of stack. So, in this lecture, I will discuss about queue and operation of queue, application of queue, and algorithm of queue. But they are the some part of remaining of stack. So, I will discuss these some remaining part of stack. So I will discuss in this lecture also. So this is the last in a last slide in a last lecture I was discuss about these valid inputs. So according to this these are the some application. So in a stack valid input, here the valid input is this. So let's suppose according this is the valid input and this one is invalid input. Means when you start any parenthesis, so you must be close this parenthesis first. So like this, according to you start then closing parenthesis, but according to there you start medium parenthesis, but and again next start small parenthesis, but you can't but you can don't close this small parenthesis, and you justly close medium parenthesis. So this is the invalid inputs. So these are the some applications of stacks. Now third part of stack, evaluating arithmetic expression. Like firstly I tell you the what is the infix notation, what is prefix notation, and what is postfix notation. So firstly I tell you infix notation means here two operator, here two operand 2 and 3, and use one operand. So according to this infix operator means, according to infix operator, the general way of writing arithmetic expression as known as a infix notation. So this one is infix notation. Also another example of infix notation. Infix notation means operator between two operand. So like this. Okay. Now comes to convert this infix operation into prefix operation. Prefix operation, here you apply firstly operator, then apply operand. So according to this diagram comes to here. So here the one operator and two operand. To convert into prefix, so first apply operator, then apply operand. Okay. Now this infix notation also convert into postfix notation. So according to this postfix notation, here A and postfix means firstly apply operand, then last apply operator. So according to this A and B and last apply this one. So this is the called infix, prefix and postfix. Same things here you can also use plus 6. So this is infix notation. Okay, this is infix notation because operator use in between operand. Okay, so now convert into prefix notation and postfix notation. So how to convert it? So prefix, according to prefix, firstly check the precedence both and check which precedent is high, then apply that. So according to this, convert into prefix. Okay. So according to this part solve first, but as a prefix. So this 2, 3. Okay. Now your expression is this form. Okay. So this is called one operand, and this is called again one operand, and this is called operator. Now again convert it into prefix. So according to prefix, operator is first apply, then first operand, after apply second operand. So this is prefix. Now comes to convert into postfix. Okay, this is infix notation, and this infix notation convert into postfix. According to postfix, first operand apply first, then second operand after operator. So according to this, firstly this is apply solved by this because precedent star here is high as compared to plus. Okay, so what is this? This is first operand, this is second operand, but convert into postfix. The postfix 2 into 3, then multiply. Okay, now same plus 6. So it is work likely first operand and this is second operand. Now convert into postfix again. So first operand 2, 3, star 6, then apply operator plus. So this is called a postfix. So got it? How to convert infix notation to prefix and how to convert infix notation to postfix. Same thing here. Now there are some evaluation. Infix to postfix. Again infix to postfix here. First some infix expression is given. Now you want to convert postfix conversion. ठीक है? तो infix conversion according to this is your first infix expression. So according to this you apply postfix. So firstly check precedent. ठीक है? This here. So this is the first high because bracket is higher precedent plus multiply and minus and all remaining other. So this is solved by firstly after solve. This is because second precedent is star, multiply, and last precedent you can use plus and minus. If your precedent is same of two operator, then you can check the associativity left to right or right to left. Okay. So according to this, here firstly you want to convert into postfix. So according to you solve first this bracket part. So according to 2 plus. Now in a postfix, first operand 4, second operand 1. Now apply third operator. The third operator is minus, then multiply 3. Here first operand here according यहाँ से यहाँ तक ये क्या हो जाएगा second operand और here third operand. Okay, now check the precedent which operator is priority. So according to this now solve here because this multiply is higher priority as compared to plus and minus. Now 2 plus this is just same. According to this first operand, second operand, then apply operator. So 4, 1 minus this is the first operand, this is use second operand. Now apply operator. Got it? Or according to this is first operand and this is second operand. Or use one operator plus. Now you can easily convert into postfix. First में 2, first operand is 2. Now apply second operand whole 4, 1 minus 3 star. Or now apply operator or operator is plus. So this is the final conversion of postfix. Got it? This is same. Now use the sum evaluation of this expression. How to evaluate this expression? According to this, you can easily insert 2. First, again you can insert 4. Means when you find the operand in given expression, you can just easily insert in your stack. But when you find any operator in given expression, then apply operation. Okay, last 2 digit. So according to this, 2 easily insert, again 4 easily can insert in stack, 1 can easily insert. But now comes to minus operator. When comes to any operator come in stack, then use last 2 value, apply this operator. So here minus is come, here minus is come. When minus is come, last 2 operator means these 2, apply this operator. So 4 minus 1 is 3, means now your new element is 3 in stack. Now your stack value is 2 and 3. 2 and 3 is what? So you can done like here. Now you can insert 3. So you can insert 3 easily. Okay. Now comes to star, means multiply. When multiply come here, the last 2 digit, 3 and 3, last 2 digit easily multiply. So answer is 9. So now you insert your stack value, last value is 9. Now this is the 2 last value, and now again comes will come next operator, this is plus. So last 2 value is 9 and 2, apply on this plus operator, 9 and 2 equal to 11. So your your stack value is last 11, means your last evaluation of this expression is 11. Got it? So this is the same thing, conversion infix to postfix. Firstly you check the sum like this, one by one apply, and you can check usually your expression. So now comes to the second data structure, that is Q. This is equally same like a stack, but this is work on FIFO principle, first in first out. Here are the 2 end, especially here is 2 end. First end is front end and second is rear end. So you can easily insert and delete data from different end. But in a stack you can only one side, from there you can insert and delete. But here in a queue use both side, insertion or for deletion. So queue is the ADT. Just ADT of queue is just similar like a stack, except the first item can be insert is the first one of the remove. Here in a stack, last item in your stack remove as a first. But according to this, first item to be inserted is the first one to be removed, means first in first out. Okay. Now placing the item Q is called the insertion. Here in a stack you use push and pop for insertion and deletion, but in a queue you use for insertion and deletion. The insertion use for NQ operation, but it is the similar. NQ operation means insertion any item in your queue, and if you want to delete your item, so you use delete, then you can use DQ operation. Okay, the NQ operation used for insertion and DQ operation used for deletion. So when you want to insert any data, then you use rear end, but if you want to delete your data, then you use front end. Okay, let's suppose same, this is a simple queue. Okay, 3, 4, 5, means if you want to insert any new data, so this is called a rear part and this is called a front part. Okay, so this is a front and this is a rear. So if you want to delete 2, so you use front end. If you want to insert any new data, then you use rear end. So same things, some operation is also apply in queue as earlier slide in a stack use push and pop. So in this slide queue we use the 2 operation NQ or DQ, same thing for using for insertion and deletion. So the Q operation is NQ. NQ means you want to insert new data in given queue, or at the end, one end, or this end is called a rear end. Okay, let's suppose this is your first data, this is your second data, first, second, third, fourth and fifth. So according to this is called a one end and this is called a second end. So here one end is front and there one end is rear. So this data is a simple row, simple queue. And now this new item, this new person want to insert this queue. So this is just insert using this end, rear end. But this person want to remove from this queue, then use this. So this is easily delete this given queue. Okay. So now comes to the DQ. DQ use for front end. Okay. DQ means delete any data from queue. Okay. Now comes to the algorithm for insertion. For here insertion we use the NQ operation. Okay. Here we use NQ operation. Same things like a stack, push, NQ operation, but we use check the rear equal to maximum size. Means rear. Let's suppose we take the 1 queue example 0, 1, 2, 3. Okay, so your maximum size is 4. Okay, here value is already inserted this way. Okay, now according to this is your front and this is your rear. Okay, now if you want to insert new data, let's suppose I want to insert 8 in this queue. So 3, 4, 7, 6. If rear equal to maximum size 1, means max size is what? 4. Or rear is present, current location is 3, means max size is 4, max minus 1 means 3 location. If rear present here and front present 0, then print queue is overflow. It means any other new node cannot insert in this queue. Okay, but so this is the first scenario will come, but in your queue have some space 3, 4, 7. Now you want to insert a new data 8 again. The 0, 1, 2, 3 and max size is same 4. Okay, now this condition is false. If condition false according to this scenario, so you will come to next part, rear equal to 1. Means you want to insert, you want to NQ operation here 8. So rear value is according to this scenario here and here present front value. And now you want to insert new data. The rear also increase by 1. So rear is increased by to this 1. So here you can easily insert your data. Got it? This algorithm used for NQ operation, means insertion any data. Q delete. Here DQ operation. Here you apply DQ operation. From DQ operation you can delete your data. Okay, if front equal to rear, what is this? Now check. Okay, it means, let's suppose not rear, it means this condition is wrong. According to this, if your front and rear both equal to -1, then print Q empty or return. Let's suppose here 0, 1, 2, 3. Okay, and here no value is present, means you want to delete, and now front and rear comes to -1. It means no data are present in this given queue, or now you want to delete given data. So if front and rear value is -1, then print queue is empty, you cannot delete any data. Okay, big Sam. Now you can insert data 1. Now can you insert first data 3, मतलब use NQ operation. Now check here. Now front value is here and also rear is here. Means front and rear both value is 0. Now check. If front and rear equal to 0, मतलब equal this one, so your data easily delete और set कर देंगे what? Front and rear को -1 पे. Okay. Now you have some data in your like this and 2. Okay. And again you want to delete, and front you want to delete here. So according to this, front is 3, 4, 2. Okay, got it. Your front is here, your delete is here. Okay, now you want to delete your data like 3, because you can delete from front. Okay, any data. So now in a front 3 is here and you want to delete this data, then front value is move by 1. Front plus 1. So here your queue show like this, front and rear. So return item. Item is what? 3. Got it? Now there are the some application of queue. First one is real life example. As you show, waiting in line. If you waiting in line, so serving only first in first out. FIFO. Waiting on hold the tech support, same thing. Application related to computer science. First one is use this round robin scheduling. This is use operating system. Okay. Now next is job scheduling. Job scheduling also work FIFO scheduling. And keyboard buffer. If you apply any number first, then show in monitor first. So it is also work as a FIFO. Okay. Now same third state of queue. State of queue, here the queue is empty, same state. Only 2 operation is occur in queue. First one is NQ for insertion and second one is DQ for deletion. But remaining some other or state are shown in queue. Let's suppose you want to check your queue is empty. Then condition you check the front and rear not equal. Front and rear equal to -1. If front and rear both are -1, then you check the queue is empty. But check here queue is full. That condition rear is equal to max -1, yeah, or we can say that the max n value. And third one is queue is element is less than front. If front is less than rear, number of element what? Rear minus front equal to front. They are the remaining other state which is used in queue. Now same thing also, this queue also represent by the two different implementation. This one is array and this one is linked list. Circular queue means like this is a simple queue. This is your front and this is your rear, but in a circular queue you use these portion 2, 3, 4, 5. 2, 3, 4, 5. So this is your and this is your. So and now comes to the, these are the some also queues. Normal queue, FIFO, circular queue, double-ended queue. In what is the double-ended queue? In a double-ended queue means in a normal queue have one end for front and one end for deletion. This is called a rear part. Okay, sorry, this is the used for insertion and this is used for front part for deletion. Okay, simple. But in a DQ you can insert also here. or you can also delete here. Means insertion and deletion both application and both operation apply in both side. So called a DQ operation. Priority queue means here queue index have one priority association with here. This is also classified into two type, ascending and descending priority queue. Here we use ascending and descending priority queue is use 2, 3, 4, 5. So according to this ascending, to have higher priority this number and have lower priority this number, but in a ascending way. But if you use the descending way, so according to this number is higher, so higher priority, or here the lower priority, but in descending priority queue. ठीक है? This is the some example. So this is the some example of this priority queue and this queue. So according to this, same on the priority example of this. So in this, so according to this, these are the some various queue: normal queue, circular queue, double-ended queue, priority queue. These are the some example of simple queue. So now, so in this lecture, I will completed about remaining part of stacks and queue introduction and operation of queue and application of queue. So thank you so much.